Just to give you a background about myself, so I'm doing automation testing from last 9 years. I started initially with as a developer, but then moved to testing. So over the past 9 years, I've worked on different aspects of automation testing, whether it was web, API, performance, mobile automation, and currently I'm more focused into big data and AI testing in my current job. So, like how the journey of JUnit5 started was I remember me and Anthem were working together and we decided to build a new framework. And the first thing that came us to mind is like, let's use TestNG. But then like we thought like there's a JUnit5. I know JUnit4 was not very good for testing for like it was not for unit testing and not for integration testing, but we saw that JUnit5 too has some features which can be a substitute for TestNG. So keeping that in mind, we went with JUnit5. So today, basically, I'll tell you the top features which JUnit5 has, some features which are missing, which are very important, but they're in the pipeline. So let's start. The PPT would be short, and I'll try to concentrate more on the demo because even I get bored when seeing too many slides and just reading through the PPTs. So let's go with the very basic features which are there in any testing tool. So you can parameterize your test. You have assertion. So what do I mean by assertion is obviously there are third-party tools like AssertJ, Hamrest, Kotlin assertion. But JUnit5 gives a very rich assertion of its own. So you can have a combination. For example, you use some assertion library from JUnit5, and then you have AssertJ, and you can use some instance from there. Test instance annotation. This is a nice feature, I feel. So, like, whenever you run a test, you're always worried about the test life cycle, the life cycle of your variables, the life cycle of your object. So in JUnit5, your life cycle could be a method life cycle or a class. What does that mean? So for example, if your life cycle is a class, that means all the objects created by that test are valid for the whole class. And any changes done to that object would reflect to any other method which the class is calling. But when you change this to method, then it becomes like a local variable. So any change done in one of the tests is not reflected against the other test. So this is important if you are sharing resources, especially DB connections, or you have a file, for example, couple of tests try to write to the same file. So obviously the whatever is written by the first test, the second test needs to append the same file rather than creating the new file. And extension and custom annotation for extensions, I'll explain that a bit later because that's one of the best features I feel JUnit5 has. And it's a bit complex and it requires some more time. And a favorite, parallel execution. So JUnit5 is still very new for parallel execution. They're still working on it. They just released a new version with parallel execution 6 months back. So I'll still say it's a new feature, but it does have like few good things for that. So in parallel execution, you can have the execution with a concurrent or same thread, and it can be configured on class level and method level. What do I mean by that? So let's say you say that your class should run concurrent, but your method should run on the same thread. This means when you do execution, each class will run on a separate thread, but the method in a class will run on the same thread. And you can do the reverse also, in which your class runs on the same thread, but the method inside the class run concurrently. And you can have a combination of this. One good thing to note about here is resource lock. So I remember when I was using TestInstance or any of the tools, whenever we did for parallel execution, the biggest challenge I had was resources. I'm using a DB connection now. One test is writing to the DB, and another thread again tries to integrate or try to contact that DB. So the synchronization problem happened. So what the resource lock does is, if a thread has put a lock on any of the resources and another thread is trying to get to that resource, it will stop the execution of the second thread. It will wait for the first thread to be over, the resource to be free, and then it will allow us to use the same resource. Isolated is still a feature which is still like they're still developing. It's basically if your test is isolated, it builds a Docker, not a Docker like an environment around it. So the test is isolated from everything else in your life cycles or other objects. So it's like an isolation, a separate environment, a separate instance for that test only. These are tests which might change your JVM or something like that. So you don't want, if you do a change in the JVM, to be reflected by some other test. And how does the parallel execution works? So you can have a dynamic, fixed, and custom. Dynamic is something what we call as like resource up and down. So you tell the compiler, based on the resources I have, you can scale up your thread and you can scale down your thread. So this is one of the very most commonly used. If you have more resources, you spun up 3 threads. If you have less resources, you just spun up 2 threads. Fixed is, as the name suggests, you say that, okay, no matter how many resources I have, don't execute more than 3 threads. That's my maximum capacity. But for fixed, try to remember that you have to make sure that you're testing all the environment always has resource available, because the framework or the JUnit5 won't care. It says you have 3 threads, it'll try to spin up 3 threads. And if there are no resources, it'll just fail. It won't have a way to scale down or scale up automatically. And custom is where you can like define like, okay, it's a dynamic execution of the threads, but I can go maximum up to 3 threads. Because if I go to more, it might be a bit difficult for me to manage, or maybe I don't have that much test that I need to have more than 3 threads. So you can have a custom that way. And these are some other features about repeated test, enable OS, and combine custom annotation. So before I move to next slide, let's have a demo on these things, because I want to make sure that I give a demo on the slides I show you, because else if I give a demo at the end, you will forget and it will be difficult to relate about the slides and the demo. So let's go to the demo part, the part which will be easier for me to speak on.
Sorry, Shashank, can you please enable your camera? It would be easier for
sure.
everybody to follow. We want to see our presenters.
Sure.
Thank you.
Am I visible?
Thank you.
I was just worried that sometimes when I on the camera, the net connection.
No problem, no problem.
Okay, great. So 1 second. So let's start with the first very basic feature that we discussed was parameterization. So I think most of us are aware, like who has worked on any other testing tool, TestNG, JUnit, or any other, that how parameterization work. So I have some couple of examples, and all this code would be shared by Anthony in Git with you. So you can later download the code if you want to like follow up like how the code was working. So the first example is a simple one where you pass parameter as an array. So if you run this test, basically each execution will take one element of an array and run through. Same way, the second one, you can pass your enum as, okay, it get executed. So it executed twice and you got like string 1 and string 2. Second one is a bit like where you can pass a enum as a parameter. So I just defined a simple enum of the week of the days. So what this test does is each enum value would be taken as part of one execution. So if you have like 7 days of a week, so this test executes 7 times, each time picking a single value, and that's why it starts printing like Monday, Tuesday, Wednesday. And even if you see your test here, there are 7 executions: 1, 2, 3, 4, 5, 6, 7. Then a more complex or advanced feature is where you can send a string builder, like you can define a method, which method is a combination of objects, like a stream of objects. For example, this one is a stream of objects which have a string, then I followed by an integer, and then an array list. So you can even pass this as a parameter here. You can have a class, enum, anything, a combination of any objects could be here. And if you run that same way, it will pick up each object as one execution and print that. This one is a favorite one, which we always use, CSV. So it's just a simple CSV that I have defined with countries and the capital. So we can pass a CSV directly like that. The CSV file source annotation provides a way to read the CSV and pass it to your test. So let's execute this one, as I know this is the most common used. So as you see, it printed both the section of the CSV, the first one row, the second row. Each column would be one of the variables. And one more like extension of CSVs, you can define, like, for example, you have a CSV of 2 lines. You can say like, I skip the first record. So if you do that, the first record, the India record it won't get printed, and you will directly move to the second record, which is UE. And you do have a exception handler here automatically inbuilt, that if you do this, so now it will give you a null point exception because you are saying that skip the first 2 lines, but your CSV itself just consists of 2 lines. So it doesn't have any parameter to run your test through. So I think this is pretty straightforward. This is something we have been working on and something which is not that complex. So second thing is about some extra features. So what are the good features? Like JUnit5 has a lot of features and it's difficult to cover all these features in one talk. But I'll try to cover the one which are most important. We have a display name. So basically, this is used for reporting, for management, or your logs. Instead of having a test name which doesn't make sense or just the method name as a test, you can define a display name. So your test will have this as a name. So if you execute this, this would be the name of your test. And one more important thing. So what I've done here is, now the display name is something that is given by the user. So for example, one user misses to give a display name. So I've just extended this to make sure that even your test method name gets converted to a logical name by using regex. So what do I mean by that is, let's go here. So if you see the, sorry, not this one. Yeah. So if you see this test, here I have not defined any display name. And let's run and see what the name of the test is. So if you see the test name, automatically the method is like converted into uppercase and the words are splitted by a space. So this happens because I've extended the class to have an extension. So this is useful. This makes sure that even if a user or a person who's writing a new test case forgets to mention a display name, still your logs will have a good logical name. So it helps in getting logs or even a report. This name sounds much better in your logs than a name without spaces, and it's sometimes difficult to read. Repeated test is as in any of the methods like the test run twice. This is a good thing that JUnit have. So you have a capability to enable disable test based on your system configuration. For example, if I say enable on Mac, this means this test will only run if your execution is from a Mac machine. So in real time, we do have some tests which should run only for Mac, or some tests which are only meant for Windows machine or for Linux. And even you can define something based on your processor. For example, if you're doing some performance testing and you feel this performance testing should only happen for a 64-bit ARM processor, it should not happen for a 62-bit machine. Or even you can define, let's say, a test using lambda expression. So you can define this test should only happen for a JRE or a JVM. So all these can be defined. So like you have these type of different OS system you can define the type of JVM you want to run it for, you can define the type of ORM you have to run on. And third thing is order by. This is same as any test. You can just order your test and you can have a conditional test execution. So basically here what I say is disable this test if this condition is true. And this condition is defined here. So this can be like if you have some complex test, like for example, only if A happens, then only execute the test 2. So these then can be fulfilled here. That can also be done by nested test, but nested test gets to a different complexity. So this is an easier way if you just want to do a conditional run. So let me run this just to show like some other test would be executed based, like the Windows test should not get executed. I am using a 64-bit processor, so only 32-bit test should not get executed. So this test was not executed because it's only enabled for Windows. Same way, this test was not executed because I'm using a 64-bit operating system. So a 32-bit architecture, the test didn't get executed. Okay. So another good feature which I like about JUnit5 is you can combine your tags and annotation. So I have a self-main annotation here, release. So let's go to this annotation. So this annotation says that it has tag smoke, known bugs, critical. So that means anywhere where you use this annotation and I run a smoke test, this test will get executed. If I run a known bug, like for example, if I run my test only tagging known bugs, then also this test gets executed. If I run tests which are critical, then also this test gets releases. And if I run a test with tagged as release, that also get executed. So how this is useful, let's say you have a production system and you know that this test is for performance, this test is critical, this has to be done for every release, and this has to be done for production environment. So rather than defining 4 tags for the same test, you can have a combined tag, important test. And you can define 4 tags under that, like smoke, critical. If you want, you can have like tag like something like performance if it's related to performance. So that way you can add multiple, there is no limitation for the tags you can add, but you can add no matter how many tags you want. For example, you can add one more tag here. So this is regarding the composite annotation that you can have. Now parallel execution. Okay. So for parallel execution, I have some cliff notes here. So basically, to enable parallel execution, this is one of the POM properties you need to have for your executor. And these two are the properties which tell what type of execution you need to have. So here what I'm saying is classes should be concurrent, but the method should run on the same test for one class. And I can even reverse this. These are the methods, like these properties will go throughout your test, but you can override them in your class. So let's take an example here. So here I'm saying the execution should happen on the same thread. That means these tests should run sequentially. Let's give it a try. Second, I don't know. Since I updated my Mac, I'm having some issue with my Java home. Okay. Okay, so the test will. So you see, first the test one started. Now it will wait for test one to finish, and then the test two starts. So both the tests are run on the same thread. Now, for example, instead of this, I make it concurrent. Let's try to run it again. Now it's expected that both the tests should start on different threads. Yeah, so see, both the tests started together. It didn't finish, it didn't wait for the first test to finish before it started the next test. So this way you can like have parallel execution, you can have resource sharing between them, and you can have any thread like which is running and it's sharing resources. So before I move to the next topic, do you have any questions on this one? Because if I ask questions at the end, you might like forget what I spoke about half an hour back. So anything you want to know more about this topic?
Folks, you can just unmute yourself and ask any question. If there is no questions, we will just continue.
Yes, Greg, Raj this side.
Hi.
Am I audible?
Yeah, you're audible.
Yeah. Could you please just ideas on the parallel execution, because in concurrent the tag execution concurrent. Suppose I want to change the order of the, definitely the execution is parallel going on. Suppose I want to the order the first test case will be. Can I change the execution flow?
Yeah, you can change the execution flow, but you have to remember order by when you run, they expect it to run sequentially. Because let's say you say order 1, 2, 3, that means you're expecting that the test case 2 should run after test case 1. But if they are running on the different threads, that won't be possible. So for that, what you can do, you can have a composite method or what you call as a composite test, which are defined of multiple tests. And in that way, you can have nested test and you can achieve by that.
Okay. Thank you.
So, okay, let's move forward. I think we don't have much questions on this. So next part is extensions. So extension, I feel, is one of the main feature, like, or one of the most powerful feature which I liked about JUnit5. So I know we have this before class, after class, before method, after method, which runs, or if you are using Cucumber, we have our hooks. All these things are there, but all things have limitation that, for example, before class, it has to be defined in every class, or you have to define in a base class, which every UI class or every API class has to extend. So somehow it comes to the person who is writing the test case to make sure that he has extended the class, or to make sure that in his before class, he has instantiated the driver, or he has instantiated the rest assured for the API login, or he has clean after execution, he makes sure that he tear down all his resources, he has clean up everything. So that comes to the user, the not user, to the person who's writing a test. But imagine that you are a good developer, means you are a developer who has just given up a good framework. So for the user, you want the person who's writing a test case that he should not do much. He should just write his test case. He should not worry about how execution is happening, how cleanup is happening, how you are doing database connection, or how you're doing some generic task. So that's where extension comes into picture. And extension comes with a very good support of what I call as a, not I call, sorry, the JUnit calls as stores. So JUnit has an inbuilt store. So what do I mean by inbuilt store is like, what happens, for example, you want to have some resources that you want to share across your test. Now, if you use an external source, you have to manage the life cycle of the resource, whether it's an object, whether it's a string, because your test works in different life cycles and your object also works in different life cycles. So what the store does is it gives you an option to have an object inside the life cycle of the test itself. So as the life cycle of test is there, that object exists and then it goes. And then you can have this store as a global store or a local store. What do you mean by global and local? A local store means the store life cycle is that test. Global means the store life cycle is the whole execution of your whole test. By test, I mean if there are like 50 tests, the whole framework. And how the object is that is the hierarchy is upwards. So if you find the object first, it'll try to locate that in your local store. For example, you're trying to find, let's say, a DB connection, whether it's up or not. So first it'll try to find your local store, the username, password, whatever you're given. If it's not able to find in your local store, it'll navigate to your global store if you have defined it and try to find it there. So what advantage you get here is you don't have to worry about when the object is getting destroyed, the scope of the object, whether it will be available to your test or not, whether it gets destroyed when your test finishes, whether you have to kill it after method, before method, it automatically take cares of that. So it's a very useful feature for me. So let's see something about extensions in more detail. Before that, yeah. So let's talk about extensions. So first example when I gave you about extensions was this. So you see here, I just have a simple extension as display name. So not this one. Yeah, let's go. Yeah. So this is one of a test where I have a extends with exception extension. So here I'll explain two things. First is extensions, and one more thing that JUnit provide is exception handler. So one of the challenges we had in our previous frameworks were that you have an exception thrown, you can have exception thrown at multiple places. You can have it on a startup method, which is before all, before each, or after each, or you can have it when you are running a method. But all of this has to be handled at one place. Now we have extension, let's say exception extension, which implements two methods, two interfaces. So what this does is, for example, now you get an exception. Let's run this one and see. So let's comment this. So first time when I'm running this test, an exception is only thrown by a method. So this will be handled by a method override. So let's go here. Let's first see the output. So if you see, oh, why, oh, sorry, let me just run it again. So because it was thrown by a method, so automatically it navigates to this path where you can handle this exception, assuming knowing that this exception was thrown by a test. But let's say in another case, the test doesn't throw an exception, but the exception is thrown by before all. This needs to be handled in a different way. Why? Because let's say your before all is setting up a web driver or it's a login. So if this is throwing an exception, it doesn't make sense to navigate through the whole test. It has to do something else. It might need to clean up resources. It might need to try to set up a web driver connection, reset the server or something. So let's try and run the same test again. So now see the exception is thrown by before all. So now this exception is caught by before all. Same way, if an exception is thrown by before each, it will be handled here, after each, and after all will be handled here. So this is how the exception handlings happen. And now coming to extensions. So when you register an extension, it's very simple to register extension. Nothing complex. You just define a class, and you just use extend with. Let's say for example, let's say I might have a WebDriver extension. Yeah. So you can just add multiple extensions. So extensions can be registered in three ways. The first way, which I've already shown you, I'm registering an extension on each class separately. It can be injected on a framework level. So you can define that, for example, let's say extension to clean up resources is registered at a framework level. That means any class which is built on your same framework will automatically have that extension. An extension is executed in sequential manner before executions. But doing by sequential, this runs first. If I add another one, it runs second. Third way, you can have it in a package level. Now, how that is beneficial? Let's say I have my UI test here. So I can define any test which is inside my UI package needs to have an extension for a WebDriver, or needs to have an extension for, if it's an API test, needs to have an extension to start an API test. Means get a rest assured instance and just set up a get post method. So this way, when I'm writing a new test, I don't need to worry how it is happening. It just works automatically. And sorry, my bad. I forgot. I explained one more thing about test instance, which I forgot to give a demo on. Sorry, I jumped between these two. So I remember I talked about this, like how, what's the difference between a per method and per class. So just jump from extensions to here for a second. So what does per class means, as I told you, is let's talk about this parameter, the dummy parameter. So when you have your life cycle as a class, that means this variable is shared across the class. Let me remove these. It's shared across the class. So when I run this class, we see that I have modified in my test one, I have modified the variable name, and it's reflected in test two because the life cycle of this variable is per class. So it is shared. Same thing if I change to method. So the life cycle of the parameter changes. So you see, first for JUnit5, though we change it to JUnit5 here, but when it comes to the second method, it still remains JUnit4 because this behaved like a local variable, a local change for the method. Sorry, yeah, coming back to our extensions, yes. So this is how we define an extension. You build a class, you just extend your test with that class. And in the class, you can define whether before all methods or whatever you need to do. So I'll talk about a couple of extensions more, which I feel are very useful for day-to-day test. So this is like, let's see an end-to-end test. See, till now I've just shown you like small tests, like just a standalone method. It doesn't come to a real life where you're literally doing testing and writing some API, UI, or some mobile test. So here I have a very simple test, which is just opens a Google page. Okay, so let's go here. So a couple of things, like, let's see what I've extended this class with. I've extended this with a test result publisher, a parameter resolver, and a WebDriver. So let's first see at the WebDriver extension. So this extensions take care of instating your WebDriver. So just to do that, I didn't need to care about anything else. I just need to extend this extension to my class. Then we have one more extension, test result publisher. So this one is a JUnit feature which you can use, like to publish a result of, like, for example, your end-to-end test cases. I run a test, I have a test case ID. If that test case ID test passes, I go and update to my manual tool. It could be a test rail, it could be a Rally, it could be Jira. I update the test case status there. And if there is a bug, I raise a issue. So how can we do that? For this, we have what is known as one of a very good interface, which is a test watcher. So test watcher gives you 4 methods: test failed, test disabled, test aborted, and test successful. So basically, if you implement this test watcher after each execution of a test, depending on what the status of the test was, based on your assertions, if it was pass, it was fail, it was a disabled, or it was aborted, you can do your processing here. For example, my processing is if a test is failed, I publish a result of test being failed. And if my test was successful, I just use a test trail to publish that the test was successful. And how do I get my instance? I use a object store, which I discussed about. So from this store, I store my test trail instance, the username, password, and whether the instance is already created or not in here. So how this help me is before even doing a new connection, I define this at a global level of the test. So first I make sure that whether I already have something like a singleton, what we call singleton in Java. So I make sure if an instance is already there for my test trail or for my Jira or for my DB. If the instance is there, then I try to get the same instance back from the store. Because the store is a global store, so this instance will remain throughout the execution of whole test. Not the test, the whole framework, all the tests to be honest. And if it's not there, then I create a new one. So this is one of a very good extension that can be used. And same here, we have an extension like you can have an exception. Like for example, if an exception happens, then you can take a screenshot, or you can take a screenshot on test fail. So like for example, for me, I do here, if it's a failure, let's take a screenshot, or if it's an API, let's just print out the logs. And even here, I have the same thing. If there is an exception in the test case, then also I can take a screenshot or do something fancy or whatever I want. So basically, this controls your life cycle very well. You don't need to worry, you don't need to worry about, okay, what happens in my test fail? Do I need to write a separate method for that? How do I need to handle my test failures? Where do I get all these features from? And just one more thing I'll show why it is important is, let's go here. I want to debug a test and show you how powerful, like from a text to debug it. Guys, are you able to hear? Stable.
Shashank, you're a little bit interrupting.
Your voice is break.
Second.
Might be some internet issue Greg from your end.
1 second. Sometimes it happens because. Is it better now?
Yeah, cool.
We can hear you. Just try to change something on your screen because it looks like it freezed.
Yeah, yes.
So now can passes?
Oh, it works now.
It works? Oh, wait.
Yes.
Sorry. So here we get a context. So I just want to show you what type of information you get in a text context. This is very important for you when when you're making reporting, or you're trying to create a Jira bug, or whatever processing you're doing after text execution. So like here you can get every which class it was executed, what type of exception you got, what was the life cycle for the test. Sorry, the display name for the test. If the test is nested, what is the parent test? What are the parameters you have passed? Is there anything that is in the store? For example, if you're storing your exception in the store. So all this information is available to you in this extension context. So this is a very rich information what I felt can be used, because what happens, like when you run your test, the main part or the main people struggle is with debugging. Okay, I've run my test, now it failed, but I don't have enough logs, or I don't have enough information for me to know how the test failed. So this context is very useful, and you can, like, whether it's a report, whether it's your log, you can use this to publish very good information for you that you can use for debugging. Okay, let's go back to our UI test. So yeah, this was my basic UI test. So here, like, I define a test case ID. This is again a custom annotation which I have built. So basically, you can pass a test case ID. This test case ID would be used to update your test case in your test tool, which could be, like, for us, it was test wheel for this example. So I won't show this end to end because I don't have a test wheel license right now, but you can use any of your tests to do that. So it can just go there and update everything, and it will be resolved in the runtime. All these IDs would be resolved at a runtime. Like, if you see, I've just defined a class here. I won't go into detail for that class, but I just defined a converter which converts your test case ID into a ID which could be read by your tool. So depending on your tool, you will customize your ID and you'll make it standardized. And then this was more about extensions. So this is one of the powerful feature which you can use. You can even override the existing extensions. They have a couple of extensions which are already there. To add a JUnit5, you can override them, or you can build your own custom extensions. And the life cycle of extension is after, like, for example, after your before all and after all, after that the extension is executed in a sequential manner. The first extension is executed first. An extension which is defined at a project level gets executed first, followed by the extension at package level, followed by the extension at the class level. So that's the hierarchy of the extensions. And I think I forgot to show you one more thing, that is for assertions. So I don't want to spend too much time on this slide, and I think I'm already running out of time. So you have this other assertion which are inbuilt. I'm not using any AssertJ or any of the third-party tools. So you have a assert all. This is very similar to soft assertion. So basically, it will assert everything. Even when one of the assertion fails, it navigates and finish all the assertions. And at the end, it gives you what assertions have failed and what assertions have passed. For example, I get my 2 assertions have failed, these 2. One thing that you can look even further, or you can see by yourself, are this test. Here, if you see, they are dependent assertions. So depending on the output of this assertion would run. So if the output for this assertion fails, the second assert won't happen at all. This is important. For example, let's say your first one is I log in into a page and then I see whether the page displayed is correct or not. So if the assertion of the login itself is failing, it doesn't make much sense to go to the assertion of verifying the heading of the page. When you cannot open the page, then it doesn't make sense to verify the heading. In such case, you can write some complex assertion which are dependent on each other. Okay. Sorry, any questions on extensions and test watchers and exception handlers?
Question from my side. How do you think, what kind of embedded extensions will be useful if you start using JUnit5? They have some kind of internal extensions. What you can recommend just to plug to the initial framework?
Yes, so they have a very good extension known as temp directory. So what that extension does is, when we run a test, sometimes we have like some resources which we save just for the life cycle of the test. We don't want to keep them after test executes. And normally what we used to do is to define a test library in a target folder, and all the runtime reports or all the runtime objects used to get stored there. So they have an extension where you can define a temp directory which remains in the cycle of the object. They have another extension for dynamic test, where it's more about dependency injection, where your test is not defined initially at a compile time. Based on the execution results and based on the test data which flows from different tests, your test is built at the runtime itself. And the extension model is more about extending the interfaces to have a custom extension model. Like, we have a display name generator, which is already an inbuilt annotation, but you extend it with the extension to make it a bit more user-friendly or to fulfill your needs. And it's a very active project, Anton. Like, if you see, they still have around 20 PR open, and the last version they got was just on 11th Feb, which had what you call as suit execution. I know someone would ask, like, the biggest problem they have in JUnit 5 is that there is no test suit. So good news for them, they have their first version, which is currently a beta version for test suit execution, and they claim at least that till the mid of this year they'll have a full-fledged suit system in JUnit 4, sorry, JUnit 5 also.
Mm-hmm. Thank you.
Any other questions?
Guys, you can just unmute yourself and ask the question now.
I think either I was very good or I was too vague for anyone to understand. I'll go with the positive one.
It's positive.
Ahmed is asking about GitHub link. The link will be shared with the recording. Shashank has a public repo on GitHub. Or if you have this link, you may just paste it here.
Otherwise, Shashank, that link, recording link, you can share in LinkedIn over, then you will get download over there.
Yeah, I'll ping the once I finish with the presentation. I'll ping the link here also. And anyways, as Anthony said, he'll share both the recordings and the PPT and the link with everyone.
Yeah.
And
Yes,
any
yes.
questions you have even after the presentation, like when you're going through the code, you feel that I've missed something or you need to have more clarity on any part of the code, feel free to just get in touch with me.
Sure. Thank you. Thank you.
Yeah. So
Shashank, provide your contact details in the chat, please.
sure, I'll do that. So yeah, now I know most of you would have this in mind. Okay, so I'm using TestNG already. I'm good with it, and so why do I go to JUnit?
Yes,
So,
that question
yeah,
comes to my mind first.
I know it was the first thing that came to my mind too. So like, let's set the record straight here. So I'm not saying that TestNG is bad or JUnit is doing something that TestNG doesn't do, or it is like a game changer. But what I felt like for any tool, like let's say for any automation tool, you have two parts of a tool. So when a tool is made like keeping testers in mind, it becomes a close-ended tool. Like if you talk about performance testing, JMeter, it's a very good tool. It's very strong, but it's a close-ended. Means you have something that you can do in a very fixed way. But if you want to play around with it, if you want to modify things, if you have to do something, you have to customize things. It's very difficult to do. But if some of you have worked with Gatling, though it's a tool which is not that mature and it requires a lot of coding, but it's more customization is there. So what, and second thing which I liked the most was, like, any company you go, what happens is now everybody's following agile. So now in agile you say that there are no testers, you have like everybody works in everything. So what happened in my project was we are already doing unit testing. So the developer comes to me and say, okay, we are using unit testing, we are using JUnit 4, they were not using JUnit 5. So now can we do some integration testing? And I said, oh, integration testing, and I need to write a different framework in TestNG. He said, why can't you use the same thing? I said, no, it's very difficult for me to do integration testing with JUnit 4. And then I wrote a separate project, and then he was not able to contribute in my project, I was not able to contribute to his project. So if you have JUnit 5, it, the developer is happy because he can write his unit test cases there, and even you can help in writing unit test cases. And same can be extended for writing writing integration test. So the pain or the problem of having two separate testing frameworks gets solved here. And especially for a project which is like not 10 years old, or like just like short projects, you have your genuine test cases. Okay, I just need one end-to-end test case. It's not a big application. I'll just use your JUnit 5 framework and write my test case there, rather than having a separate project with TestNG. So I've tried to do a one-to-one comparison. It's debatable. I know some people, we might agree, some might not agree. Even I'm not very agreeable on all the things, but these are the important features, and I've tried to compare this. So extensions. So TestNG doesn't have extension, but it has listeners. Listeners are powerful, but they're limited. I know you can override a listener, but if someone has tried to customize a listener, he'll know like how difficult it is to register that listener, to make sure that the life cycle of the listener is correct. it's a bit painful. So I feel when it comes to extension versus listeners, JUnit have a slight edge. When it comes to parameters, they both are mature enough. I think you have all the type of parameters, whether you want to pass a class, you want to pass an array, you want to pass an object, CSV. Even if you want to pass an Excel, you can overwrite your CSV extension to read an Excel and convert it into CSV. So I think both are pretty mature in this part. Now parallel test. Here I think JUnit still needs to mature. As I told you, initially when they launched in 2016, I think 2016 somewhere in fall of 2016, they didn't even have a concept of parallel test because they were more focused on unit testing, and unit testing doesn't require parallel testing. But they have come up with this feature which works very well, but it can be mature more. And I think why I say it's not that much mature, because parallel testing comes into picture when you have suits, because no one wants to run each of the methods parallelly or each of the class. That's too much to do, and it's like overhead. Basically you want to run a suits parallelly, the smoke suit and a regression suit to run parallelly, or we have like different features to run parallelly. So I think once they get a suit concept integrated in JUnit 5 and a bit of changes in parallel test, then it'll get better. Like one of the problem that parallel test execution has is with reporting. If you're using something like extent report or other reports, parallel test execution are not able to create a separate thread in JUnit 5 for all this reporting. So sometimes it becomes a bit messy and you have to write custom handlers for that. Customization, as I said, JUnit 5 is an open-ended tool. It has, you can customize it the way you want. Means, because I'll tell you the reason for that. So testng, you get one package. You just import a testng package and you get everything here. Now JUnit 5, you have a JUnit 5 API, you have your JUnit 5 runner, and you have your JUnit 5 compiler. So because these three are different components, so first time it looks a bit complex that why do I need to have three different components? But what flexibility it gives is each of this component can be modified separately. For example, if you have JUnit 4 test cases, they can directly run on JUnit 5 because the compiler for JUnit 5 suppose JUnit 4. So that gives you advantage over that. Test tags, both are very good in test tags. You can have multiple text tags. You can have, as I showed you, composite annotations. You can have whatever test tags you want. It's almost the same. For built-in tools, both have good support for built-in tools. TestNG has a better support for, well, say testing tools, but still I think there is, because of the I've not seen any tool whether it's a third-party assertion library or third-party reporting library or third-party, let's say, a Spring framework or any framework which is saying that they are not supporting JUnit 5. So I feel that both of them have a good support. One thing that TestNG doesn't have, I've not mentioned here, as I said, JUnit have a very good disable enable feature. I just showed you a couple of things in disable enable, but you can even disable based on your, let's say if you are at CI integration, you can say that if my CI integration is true, then run this test, else don't run it. So that disable enable features is very vast. You have like, I won't say like multiple options. Your operating system, your processor, your CI/CD integration, your JVM, and even you can overwrite. For example, you feel I want to have a disable enable based on the my name, you can customize it. So that's the power of JUnit 5. You can customize and you can extend and do whatever you want with it in the scope of JUnit 5 executor. Okay, guys, that's all from my side. I hope it was not very boring. It may be a bit boring, but not very boring. And
It was
you got
great.
something
It
out
was
of it
great.
at least. So
Thank
any
you,
other
Shashank.
questions we have for this?
It was great. It was great.
Thank you.
Yeah, it's
So,
great,
guys,
Shashank, because
you can ask any question. Just unmute yourself. I just want to mention that, as you said, people are struggling maybe because they think they have to rewrite all the existing test cases if they have, for example, JUnit 4. But to run JUnit 4 test, you don't need anything. It works out of the box. You can switch your runner to JUnit 5 and then just add new test cases based on JUnit 5, and all your rest will still work, and you just maintain this bunch of tests. And I think this is really powerful because I believe no one wants to rewrite the project from scratch. And this JUnit5 gives you ability just to proceed, and it doesn't force you to rewrite everything. You can just slowly move forward.
Yes, agreed, Anthony. That's one of the most, because any tool should have a backward compatibility, else it's very difficult to use without backward compatibility.
Okay, great. Thank you again.